In this video, we're going to talk more about quadratic functions, specifically finding the vertex of a quadratic function. So the vertex of a quadratic function is that highest or lowest point on the graph of the quadratic function. So here's an example of a parabola that opens up, right? And so this parabola will have a lowest point, and that's right there at the bottom. It will not have a highest point because the graph just keeps going up and up like this. Similarly, if the graph opens down like this, then the graph will have a highest point up there, and that highest point is called the vertex. So it's either the highest point or the lowest point on the graph. So one of the things that we need to be able to do is to find the vertex given the formula. So finding the vertex, the x-coordinate of the vertex is going to be minus b over 2a. If you have the vertex in, this should say general form here. And I'm used to calling this the standard form and the other form called the vertex form. So this should be general. Our book kind of reverses that. So the general form is ax squared plus bx plus c. The x-coordinate of the vertex is minus b over 2a. So all you really need to do to find the vertex is to figure out what your a and your b are and use this formula to do that. Okay, that's a fairly easy way to do that. There is another way to find the vertex through completing the square, but for the time being, we're just going to go through it this way here. So where does that minus b over 2a come from? You might think of it at, we talked about the quadratic formula already, right? It's minus b and then plus or minus the square root of b squared minus 4ac all over 2a. Okay, I'm not going to write the rest of this because it's very clunky to write with this tool here, but that minus b over 2a part is this part, right, of the quadratic formula there. And remember, this is for finding solutions to the quadratic equation, right? And so what that means is that when you look at this, the plus or minus part, that vertex, right, this formula will give you, say, like in this way I've drawn this parabola, it will give you these two solutions. If you'll notice, and my drawing is really bad, if I go back maybe and look at this really good drawing right here, you can see that that vertex is kind of right directly between these two zeros, these two x-intercepts. So it's kind of right in between there, halfway in the middle between these two. And so so that's where that minus b over 2a is. The plus or minus, right? And the rest of the part will give you the plus one will give you one of these, and the other will give you a minus. But this formula is basically giving you that as the distance above and below the vertex. So the vertex x-coordinate will be halfway in between here. So that's roughly where it comes from. Once you find the x-coordinate of the vertex, then all you need to do is to plug that x-coordinate into the quadratic, and that will give you the y-coordinate. And so you'll have the x and the y-coordinate. All right, so that's what we're going to do. We're going to look at 3 examples in the rest of this video of how to do that. All right, I'm going to switch over to here. All right, so we're going to find the vertex of this quadratic function, minus 1/2 squared plus x plus 4. All right, so first making sure that it's in the general form, we find the a, it's negative 1/2. The b is going to be 1. Okay, and then our formula is minus b over 2a. So that minus is going to be out in front. B was 1, right? So that goes in here. And then the a was negative a half. So on the bottom, I have 2 times negative 1/2. Next up, I'm going to multiply. 2 times negative 1/2 is negative 1. 1 divided by a negative 1 is negative 1, and then the opposite of negative 1 is positive 1. So that's the x coordinate of the vertex there. All right, and then next up, I'm going to take the 1 and plug it into the original, right? So find f of 1, because that will give me the y value that corresponds to this x value, and that's what I want, right? So taking that 1 and plugging it in here, I'll have negative a half times negative a half times 1 squared, and then plus 1 plus 4. Okay, so I'm just taking this 1 right here and plugging it in right for x in this formula, and that's what I'm getting right here. And then I just need to simplify that out. Again, going by the order of operations, right? 1 squared is 1. 1 times negative 1/2 is negative 1/2. All right, then I added this 4 and the 1 to get a 5. And now here I need to get a common denominator, which is 2, right? So 5 over 1, and I would multiply top and bottom by 2 over 2 to get 10 halves. Okay, and then here I have negative 1/2 plus 10 halves. That's going to give me 9 halves, right? And so the vertex is going to be 1 comma 9 halves. So let's take a look at the graph, which I moved over here. Let me move that back. All right, so the vertex is right here on Desmos. You can just click, and you can see, hey, there's the vertex, right, at 1 comma 4.5, which is exactly the same as 9 halves. Okay, next example. Find the vertex of the quadratic function, f of x equals x squared plus 1. All right. So looking at this example, you got to make sure that it's written in the general format first, and it kind of is, right? Although there is no x term, and so we can see that having x squared plus 1 is the same as having x squared plus 0x plus 1. In algebra, we don't normally write this 0x because it's just easier to not write it, and it's simpler, so that's better, generally speaking. But here we really need to focus on the fact that that x is missing, and so therefore the actual number would be 0 here, right? Because that's what we are using in our formula to find the vertex, right? We need to know, okay, the a is 1 and the b here is 0, okay? All right, and once we know what a and b is, then we can just go straight to the formula. B is 0, a is 1. Multiply here, I get 2 times 1 is 2. 0 divided by 2 is just 0. And then the opposite of 0 is, again, 0 itself. So we know that the x coordinate, right, of that vertex is 0. And then to find the y coordinate, all we need to do is plug 0 back into this function and get, so take that 0, right, plug it right back in here for x, and in here we get 0 squared plus 1. 0 squared is 0, and then adding 1, I get 1. So that makes the vertex 0, 1. Okay. And let's look at the graph. Probably, no, lost it. There we go, right here. And there we can see there's the vertex at the point 0, 1 for that quadratic. All right, next up is this quadratic, minus x squared minus 2x. So make sure that it's written in the general format, which it is, and then the numbers, A would be the number with x squared, which is a -1, and B, right, would be a -2, right? You have to make sure you take that minus with the number itself. All right, and now we know that the x coordinate is -b over 2a. So that minus out front still stays there, and I'll also have a -2 for b. Okay, and then 2 times minus a, or a, which is -1. And then just start working through that. On top I get, on the bottom rather, I get 2 times -1 is -2. -2 divided by -2 is a +1, and then the opposite of 1 is -1. So that's the x coordinate of the vertex. Next up, I take that -1 and plug it back into x, into the original. So f of -1 would look like this. And then again, going by the order of operations, the first thing I would do is do the exponents, right, first, since everything in parentheses is already done. And -1 squared is -1 times -1, which is a +1, right? But that minus is still out in front, okay? All right, and then the opposite of +1 is -1, and then -2 times a -1 is a +2. So I wind up with -1 plus a +2. That comes out to be equal to 1. So that can be a little bit tricky, right, when you have a negative sign and then a negative number out in front, or and then in front of a squared x, right? And then you're also plugging in negative numbers. You need to be careful about how that's done, and it's easy to make a mistake if you're not careful. Okay, and so the vertex here is going to be -1 and 1. And let's just verify that on the graph. And that's our third example here. And you can see there it is, right? The vertex is at -1, 1. Okay. All right, that's it for this video.